We're going to take a look at probability with tree diagrams. So tree diagrams really are just a visual so that you're able to see how probability works. You're able to visualize all the outcomes. So in this example, there's a bag, and the bag has 4 cherry candy and 6 melon candy. So in all, the number of candy, 10. So you need to pick 2 from the bag. So the way the tree works is every time that a choice has to happen, you see the choices that are available. So if you start right here, that's you little, your big brain, let's say. So that's you. And your choices are either you will go ahead and pick a cherry candy, let's call that C, or you go in the other direction and pick a melon candy. And again, that's the first time you pick. So let's call that first pick. Now, after you pick your first candy, it says to pick a second. So again, either you pick a cherry or you pick a melon. You could go either direction. If you picked a melon, either the second choice could either be a cherry or another melon. So that second line there is for our second pick. Now, the question is asking, what is the probability that the 2 candy chosen are different? Well, you can have 2 different candy if you first picked a cherry and then went ahead and picked a melon. Or you can have 2 different candy if you first picked a melon and then went ahead and picked a cherry. So that's the way you can have 2 different types of candy. So now, how do you actually use this visual? Well, first of all, we need to get numbers in our tree diagram. So because there were 10 candies in all, 10 pieces of candy in all, the 4 cherry and the 6 lemon, the total is out of 10. The chance that you first pick a cherry is 4 out of 10 because 4 of the 10 pieces of candy were cherry. So now the chance that you picked a melon is everything else. There's 6 melon, so it's 6 out of 10. Now let's look up here. So we're looking up here where we have our candy or cherry candy. So if you had first picked a cherry candy, so if you had gone up that branch and picked a cherry, you'd have 1 fewer cherry. So instead of having 4 cherry, how many cherry would you have now? You would have 3 cherry if you picked a cherry. And overall, there would be 1 fewer candy, so it would be out of 9. But again, if you went up that branch, that means you did not mess with the melon at all. You did not pick a melon. They were 6 melon before, there's still 6 melon. So the chance here of picking a melon is still 6, but now out of 9 because you had chosen a cherry. So a good way to check yourself is each set of branches. So for example, 4/10 and 6/10 have to add up to a whole. And now over here, 3/9 and 6/9 add up to a whole. So we're good. So going down the other direction, let's say you first picked a melon. So if you went down this direction and first picked a melon, there's 1 fewer melon. So now it's 5 melon out of, and again, the total is also less because you picked a melon out of the bag. So it's 5 out of 9. And cherry, we didn't mess with it, so it's still 4 out of 9, 1 fewer in the total. And that's what our tree looks like. How do we use these numbers though? So if we want 2 different candy, again, it could be cherry. That C looks terrible, so let's fix it for a second. All right, it could be either cherry and melon, or it could be melon and cherry. So what does that mean? Every time you see and, we have to multiply. Every time we see or, we have to add. So cherry was 4 over 10, and I'm looking at the tree. And so we multiply melon 6 out of 9. So that came from right here. Or, so we add melon, which was 6 out of 10, and so we multiply cherry, which was 4 out of 9. So when we calculate all of that, we should get, let's see, 24 over 90 plus 24 over 90, which gives us 48 over 90. Now, let's see where we could go from here. So this question looks a lot different, but it's actually very, very similar. So the question says that the chance of rain tomorrow is 20%, and the chance that there's no rain is 60%. Now, if it rains, you may walk to school, you may not. If it doesn't rain, you may walk to school, you may not. So at the very beginning, here you are contemplating, well, is it going to rain or isn't it? So there could be rain, perhaps there could be no rain. Now, if there is rain, what could then happen? Well, if there's rain, perhaps you might walk. Or maybe you won't walk. Let's call that no walk. Ah. All right. If there's no rain, same. Maybe you'll walk. Maybe you won't. So now we're looking at all our possibilities. So now, since there is a 20% chance of rain, we would put our 20% here on our tree. However, since we know we're going to do multiplication, it might be a good idea to convert that to decimal first. So let's move that over 2 places to the left, and we get on our tree 0.2. Now, if the chance of rain is 0.2, then the chance of no rain is everything else out of 1. So when you add up your set of branches, please make sure you get one whole. So even though the question didn't say the chance of no rain is 80% or 0.8, you know it's everything else. Okay, so now if it rains, the chance that you will walk is 5%. So again, we want to convert that over to a decimal, 2 places to the left. And so if it rains, the chance you walk is 0.05. And everything else is the chance that you do not walk. If it does not rain, the chance that you will walk is 60%. Oh boy. Okay, it looks like I have this backwards, which is okay. Let's fix it. It seems this person here likes to walk in the rain more than good weather, so let's fix that. So the question says there is a 20% chance of rain. If it rains, there is a 60% chance that you'll walk. What a crazy. All right, so let's fix that. 0.6, and then here, everything else, 0.4. If it does not rain, there's only a 5% chance that you will walk. So 0.05 here and 0.95 here. Who likes to walk more in the rain? Well, clearly this person does. All right, so at that point, the probability that you will walk, well, you can walk in 2 different ways. Either you walk when it rains, or you walk when it doesn't rain. So that's the same thing as saying rain and walk, or rain and no walk. Every time you say and, you multiply. Every time you say or, you add. So let's see what happens here. Rain, 0.2, and walk, so times 0.6. Or, so we add no rain, 0.8, and walk, times 0.05. And when you calculate that, you should get 0.16.